All right, we're talking about rational roots. Well, we're talking about roots. Roots are solutions of the equation. What do you get? What values of x will work in this equation? So we can't factor. We can't use quadratic formula because these are not x squared equations. They're x cubed or x to the fourth. So we have to come about it a different way. What we're going to do is we are going to find what we call the possible rational roots. Rather than just pick numbers out of a hat and keep plugging them in to find something that works, let's narrow it down, look at the numbers, and see what's even possible. We're going to make a list out of that so that we have a little bit less to have to focus on. All right, rational means we're not dealing with square roots just yet. And so there is a formula to finding this list of possible rational roots. It is the factors of the constant. What is the constant? Constant term is the number that has no variable. So for example, right over here, it would be a 6. And this should say equals 0. Okay, so I want the factors of 6 divided by the factors of the leading coefficient. The leading coefficient is, if they're written in order, it's the very first coefficient. It's the number in front of the highest degree term. And if they're written in order, it's the first one. So I'm going to take the factors of 6. 1 times 6, 2 times 3, and put those one at a time over the factors of 2, which is 1 times 2. So what I'm going to do is list my possible rational roots, and we're going to label that as P, R, R. Now, I haven't talked about signs yet, and we don't want to. We want to keep our options open for both possibilities, positive or negative. So in front of our list, we are going to just write plus or minus and use a set bracket. All right, I want all of these numbers over 1 and all of these numbers over 2. So I have 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Each of these over 1. Now I'm going to make the fraction of each of these over 2. 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Now, this is my rough draft. This is not my final answer. My final answer will come down here. But I have to abide by 2 rules when I'm doing my possible rational roots. Rule number 1, no repeats of roots. So I can't have any repeats. Well, let's see. 1, 2, 3, 6, 1/2, 2 over 2. 2 over 2 is 1, and I already have a 1. So I'm going to cancel out. That's a repeat. That's an extra one. 3 over 2, I don't have that yet. 6 over 2, that's 3. So I'm going to cross that off. Rule number 2 says I have to put the roots in numerical order. Okay. Well, 1, 2, 3, and 6 are in the right order. But I still have this 1/2 and this 3 over 2. I am not changing this to 1.5 or 1.5. I'm going to leave it. But changing it in my head to 1.5 helps me put it in order. 1/2 is the smallest. Then comes 1. Then comes 1.5. Then comes 2, 3, and 6. And there's my list of possible rational roots. So if you're asked, list the possible rational roots, you have plus or minus, brackets, and you have all your values, these numbers over these numbers, no repeats, and put in numerical order. All right, but of course, I have to ask more. So let's go here. Oh, this is a mess. We want to actually find those roots. I don't want to just list what's possible. I want to figure out what actually works. So the first thing I'm going to do is list the possible rational roots. I'm going to find what's possible. And then I'm going to take those numbers and plug them in and see what works. So first let's start. Oh, I'll use red. the factors of the constant. That's an 8. Sorry about that. 1 times 8 and 2 times 4. Over the factors of the leading coefficient. Ooh, that's just a 1. I like that. It's my handy dandy eraser here. Okay, so the possible rational roots is a set of plus or minus the set of each of these numbers over 1. I don't have to do it twice. I don't have to do these over 1 and these over the other 1, because that would just give me repeats that I'm going to have to cancel out. So I have 1 over 1, 2 over 1, 4 over 1, and 8 over 1. And those are my roots. Now, for my possible roots. Now, step 2. Use synthetic division to find a root that works. Hint, we're looking for a remainder of 0. All right? So, synthetic division means that I am going to use the coefficients 1, 3, -6, and -8. And I am going to, well, I'll bring down the first one, set it all up. And now what I'm going to do is I'm going to pick a number from my list of what's possible. Now, can't stress this enough. Do not pick the highest number. We have some tricks on something called upper bound and lower bound that will help me not have to do 8 synthetic divisions. How'd I get 8? There's 4 positives and 4 negatives here. So I don't want to have to do all 8 of them. It's better than just picking random numbers out of thin air, but still, I'm lazy. And I don't want to do 8. So never pick the highest number. You ever played the high-low game? Where if I said I picked a number between 1 and 100, you guess. And if you guess 70, and I say lower, you have now eliminated 71 all the way up to 100. You don't have to even worry about those. It's kind of like what we're doing here. I'm going to pick 4. Synthetic division says 4 times 1 is 4. Add and get 7. 4 times 7 is 28. Add and get 22. 4 times 22 is 88. Oh my goodness. Add and get 80. Is that a root? Is the remainder 0? No. But I just discovered something. If I look at all my answers, that's not 0, but they all have the same sign. They're all positive, 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 positive. So that means I have something special. I have something called an upper bound. Back to that high-low game. Not only is 4 not a root, it's kind of like a ceiling. An upper bound is like a ceiling. So that means not only does 4 not work, 8's not going to work. I don't even need to waste my time even dealing with an 8. So I kind of knocked out 2 birds with 1 stone. So now moving down the road, let me try it 2. And I'm going to separate these so that you can see. And they don't get too confusing. Let's start again. 1, 3, -6, -8. Bring down the 1. 2 times 1 is 2. Add them and get 5. 2 times 5 is 10. Add them and get 4. 2 times 4 is 8. Woohoo! Add them and get 0. I found one. Now, our goal is to find the roots. This was an x cubed, which means there are 3 roots. It's an x to the 3rd. There should be 3 roots. Roots are solutions, values of x that will work. So I just found that 2 works. Write it down right away in an answer box or whatever. I can just make a box if I want. All right, and put that one in there. All right. Use synthetic division to find a root with a remainder of 0. Okay, now, factor or use quadratic formula for the remaining 2 roots. I have these numbers left over when I've divided. So, what do they represent? They represent 1x squared plus 5x plus 4. I can factor that. X squared is x times x. What 2 numbers multiply to give me 4, but add up to 5? That would be 4 and 1. What value of x makes that 0? Negative 4. What value of x makes that 0? Negative 1. So, 2, negative 4, and negative 1 are my three solutions. Now, what if you didn't notice that you could factor that, and you went, I didn't catch that? Well, that's okay, because 1, 5, and 4 happen to represent A, B, and C in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, negative 5 plus or minus the square root of 25 minus 16 all over 2. What's 25 minus 16? 9. And what's the square root of 9? Square root of 9 is 3. Now, you can keep going. What's negative 5 plus 3? It is negative 2. What is negative 5 minus 3? It is negative 8. And what is negative 2 divided by 2? Negative 1. What is negative 8 divided by 2? Negative 4. See, I got the same second and third answers. But just don't forget this one over here. A lot of people will write these two down and forget this one. So I have my three solutions. I factored and used quadratic formula and got the same answers. Now, one more. And hopefully this time the recorder won't shut down on me. All right. Here we go again. Let's try the same thing. I'll use red. Find the roots. All right, step 1, possible rational roots. Possible rational roots. Oh, yay. The factors of 18. 1 times 18, 2 times 9, and 3 times 6. The factors of the leading coefficient, yay, are 1 and 1. Or just 1. So, I have 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, and 18 over 1. I'm going to plug these into quadratic formula in hopes of finding a root, and then I can move from there. Okay. I like to keep those separate. Again, I'm not going to pick 18. But you know what? I have quite a few in here. So I'm going to go down to 6, and I'm going to try 6. Uh-oh. Maybe this one will work better. Maybe this one will work better. Let's see. 1. Oh, yeah. Negative 2, 1, and 18. I got these from here. The coefficients. 1, negative 2, 1, and 18. All right. Now, try the 6. Bring down the 1. 6 times 1 is 6. Add and get 4. Multiply and get 24. Add and get 25. Multiply and get 150. At this point, I already know it's not going to be a root. But not only is it not a root, it's an upper bound. I'll just write UB. It's an upper bound, which means not only does 6 not work, 9 won't work, and 18 won't work. I don't want to cross them off because negative 9 is still on the table. Negative 6 is still on the table, so I don't want to cross them off. But 6 does not work, so let's try 2. I'm going to skip 3 and move to 2. Maybe that's an upper bound. 168 is a high number, so maybe there's some wiggle room there. And I can skip 3 is my hope. All right, 1, multiply and get 2, add and get 0. Multiply and get 0, add and get 1. Multiply and get 2, add and get 20. It's not a root. And there's mixed thoughts on this, but that should be considered an upper bound. So I'm not going to do 3. Well, I only have 1 left. That's 1. 1, negative 2. I'm sure this one will work. 1 times 1 is 1, add and get negative 1. Multiply and get negative 1, add and get 0. Multiply and get 0. Uh-oh, that didn't work either. Something's not right here. Well, there's no guarantee that these will work, but there is for me. Like, if I'm going to give you a problem, it's going to have an answer. So I've tried all my positives, and I've eliminated some I didn't try because they were part of an upper bound. So what do? I've run out of them. Actually, I have not run out of them, because I've tried all the positives. Now I have to try the negatives. Yay! So I'll skip negative 1 and go to negative 2. 1, negative 2, 1, 18. And at this point, you also want to double check and make sure you have all your signs and your numbers right, because that would really be frustrating if I did all this and I was using the wrong numbers. Bring down the 1, multiply and get negative 2. Add and get negative 4. Multiply and get 8. Add and get 9. Multiply, oh looky here, add and get 0. I found one that works. So let's put that over here. X equals, and negative 2 is one of my solutions. All right. Now, question, can I factor this? Are there two numbers that multiply to give me 9, but add, because there's no sign, so it's assumed a plus, and add to negative 4? I can't think of anything. Which means since factoring won't work, I have to use quadratic formula. So, x equals negative b, that's a positive 4, plus or minus the square root of. Be very careful. Put that negative 4 in parentheses. I don't care if your calculator tells you that negative 4 squared is negative 16. You put it in wrong. Negative 4 times negative 4 is positive, and it always will be. So make sure that that's a positive value. Minus 4 times a times c, all over 2a. All right, let's simplify this a little bit. Negative 4 squared is 16. 4 times 1 times 9 is 36. Well, I'll go ahead. 16 minus 36 is negative 20. Uh-oh. So, officially, I have finished the problem. Okay? I have 4 plus or minus the square root of negative 20 over 2. The plus or minus is what gives me my other two answers. One's 4 plus, the other's 4 minus. However, I can't leave a square root of negative 20. We've already kind of been down this road, so you should know what to do. Let's break it down. Negative 20 is negative 1 times 5 times 4. And 4 is 2 times 2. I have a pair of 2's that can get crossed off and put on the outside. And I have a negative 1, which can get crossed off and be put on the outside as I. So, I have 4 plus or minus 2i times the square root, what's left, of 5, all over 2. Whew, done. Not done. There's still one more thing you can do. Here we go. But I promise this is the last thing. All 3 of these can be divided by 2. So, divide that by 2 and get 2. Divide that by 2 and get 1. Divide that by 2 and get 1. Now what is this when I'm finished? It is 2 plus or minus 1i times the square root of 5 all over 1, which is just this. Yay. I know, that was a tough one, but it shows you everything. It shows you how we tried all the positives and they didn't work, but then we tried the negatives and we found a solution. We found an upper bound, so that helped me narrow down my options. We then took these 3. We could not factor, so we had to use quadratic formula. When I got my answer for quadratic formula of 4 plus or minus the square root of negative 20, all over 2, I wasn't done because I can break down the negative 20 and I can simplify and get negative 2 is one answer. And the other answer would be 2 plus I times the square root of 5 And the third answer is 2 minus I times the square root of 5. If the question asks for the possible rational roots, you make this list and you're done. If it asks you to find the roots, you make this list, you use synthetic division, find a root with a 0 remainder, and then you can take what's left over and either factor it or use quadratic formula. A lot of work, but it's not too complicated as long as you just are careful. Good luck.